Hello friends, welcome to Susan and John MathTube. In today's video, we are going to learn about the hypergeometric distribution. In the last two videos, we learned about the binomial distribution and then the Poisson distribution. The binomial and Poisson are two special distributions of the discrete probability distribution function. And now we have a third one, that is the hypergeometric distribution. And as always, let's start with the conditions to apply hypergeometric distribution. Just assume that you have a lot of n items. That is, you have a collection of capital N number of items. Now just imagine out of this n, A are special items. You can imagine the color. Let's say out of n number of items, A are white in color, or maybe A are defective items, or A number of items has some sort of property. Out of this n, what we do is we select a sample of size small n. Okay, now wait a minute. This sounds exactly like our binomial. No, wait a minute. I said take a sample of size n. I didn't use the word independently. So that's the difference between binomial and hypergeometric. So I never committed the word independently. In binomial, each and every trial should be repeated independently so that the probability remains the same. In hypergeometric, we do not have that condition. Okay, so I'll repeat once more. How many items do we have? Capital N. And how many of them have some special property? Okay, that is A number of items. And from this lot, you are selecting a sample of size n. Of course, randomly, not independently. And as always, we are interested in the probability of x number of success. Of course, capital X stands for the discrete random variable associated with the number of special items. So look at this. We selected a sample of size n, and how many should be with special property? X. That is what I told you here. We have to find the probability that x will have that special property. Okay, the formula is a little bit hard to by heart. So the best method is learn the derivation. That will be the easiest way to remember the formula. So once more, we have capital N number of items and A are special. And that of course implies N minus A are not that special. So here we go. Okay. And from this capital N, you selected a sample of size n. And you're trying to find the probability. You will get x which has those special properties. And of course, that implies you're going to get n minus x which are not that special. Okay, now let's write the probability. You had capital N number of items and you're going to select small n. So the denominator is going to be capital N C small n. Because you have n items and you selected n, and all the possibilities are given by NCN. Okay, now A has special properties and you're going to select x. So that will be ACX. And for the other part, it will be n minus A Cn minus x. And this is going to happen together. So there will be an and that and will change into multiplication. So this is the formula for hypergeometric distribution, and you're supposed to by heart it. Okay, so once more, we have capital N number of items of which A has some sort of special properties, and from this lot you selected a sample of size small n, and we are trying to find the probability X of them will have the special property. And it's very simple to write. Just draw this diagram and you can mark the other part. Look at this. If A are special, then capital N minus A are not that special. And if you want X to be of X special items, that implies n minus x will not be that special. And with this, we can write the probability very easily. That is ACX multiplied by n minus A, n minus x. Let's find one question paper from your past year's question paper. Okay, I hope you can read this. So if you are not able to read that clearly, please tell me. You can email me or you can put it in the comment box below. Okay, anyway, I'll read it for you. So we have a quality control engineer and he's inspecting a random sample of 4 batteries from a lot of 24 batteries. Okay, so which is ready for shipment. Okay, and he knows something. He knows that such a lot usually contains 6 batteries which are slightly defective. And as usual, they are asking us to find the probability none will be defective, at least 2 of them will be defective, etc., etc. So I'll read the question once more. A quality control engineer inspects a random sample of 4 batteries from a lot of 24 car batteries that is ready to shipment. If such a lot contains 6 batteries with slight defects, what are the probabilities that 1, 2, 3? Okay, now look at this. The engineer selected a sample of 4 batteries. It is not written whether he is doing it independently, whether he is taking one, putting it back and shuffling it. Nothing like that is given. So we cannot apply binomial distribution here. So the perfect distribution here is hypergeometric distribution. So look at this. We have capital N is equal to 24. It's given from a lot of 24 batteries. And he's selecting small n is equal to 4 batteries. And he knows very well that in a lot of 24 batteries, 6 will be having some sort of slight defects. So look at this, perfectly hypergeometric. We know that there are 24 batteries and 6 of them are special. And here that special of course means the number of batteries which will have slight defects. So start writing like this. I hope you're ready with a pen and a paper as usual. So please write. Let capital X be the discrete random variable associated with the number of batteries with slight defect. So what is capital X? Yeah, the discrete random variable which is associated with the number of things which are special. Okay, now let's complete the table. As I told you before, if A items are special, then n minus a, that will be 18 will be not that special. And in this context, they are the batteries which are like okay, which do not have defects. And from here, we need the probability of x number of success, and that means n minus x will be failures. So let's write the probability. Probability of x is equal to x. It's really good if you can by heart the probability, but if you don't have that skill, you can use this. That will be capital N C small n and ACX multiplied by n minus AC n minus x. And let's substitute. I forgot to write one thing. This is the notation. Look at this. Capital X follows hypergeometric distribution, and first we write the required number of success, and then capital N 24 and the number of special batteries, and the sample size is 4. Okay, now let's substitute. Actually, this step should come before this. So probability of x is equal to x. So a is 6, so 6cx. n minus a, that is 18c4 minus x. The whole divided by capital N C small n. If you have completed up to this, it means you almost completed the problem. Even though we didn't start part 1, part 2, part 3, it's kind of like saying we have completed 90% of our work. Okay, so the first part, what is the probability that none of the batteries will be defective? So that means we want probability of x is equal to 0. Okay, go ahead, substitute. So that will be 6c0 and multiplied by 18c4 minus 0, the whole divided by 24c4. Okay, now grab a calculator and find it. So the answer is 0.28797, or it's kind of like we have 28% chance that there will be 0 number of defective items. Now let's go for the second part. So the second part is at least. So I think you know the word at least. At least means greater than or equal to. So the second part tells us find the probability the number of defective items, that is capital X, is greater than or equal to 2. And greater than or equal to 2 means it can be 2 or maybe 3 or maybe 4, because he's selecting up to 4 batteries. Anyway, I don't want to do 2, 3, 4 everything, so I'm going to apply the trick, the usual trick. So I'm going to write less than 2. If you have any confusion in this part, please make sure you watch the first 2-3 videos in probability distribution function. And that will be 1 minus probability of, tell me all the numbers which are less than 2. So the possibilities are 0 and 1. And that gives me 1 minus, don't forget this bracket. In the last video also I told you, the bracket is very, very important. X is equal to 0 plus probability of x is equal to 1. That's it. Now just plug in all those values. So we're going to get 1 minus 6c0, 18c4 minus 0, the whole divided by 24c4. This minus will go inside. So 6c1, 18c3, the whole divided by 24c4. So that gives me 0.2513 Okay, and the last one. Okay, so they are asking at most, so that means less than or equal to. So the required probability is probability the number of defectives less than or equal to 3. Now less than or equal to 3 means 0, 1, 2, 3. No, I am not going to do that. So I am going to find probability of x greater than 3. And that will be 1 minus probability of x is equal to 4, because the number greater than 3 is 4, because we do select 4 batteries. We selected 4 batteries. And that will be 1 minus 6C4, 18C4 minus 4, the whole divided by over here 24C4. And the answer is 0.9986. So probability x is less than or equal to 3 is very high, 99.86%. Okay, so I hope you understood when to apply binomial. So I hope you understood when to apply hypergeometric and how to apply hypergeometric. Anyway, let's try one more question from your past year's question paper. Okay, so this is our question. Anyway, there's a theory question that you can ignore that part, so I'll cancel it. We'll discuss the theory questions in the examination preparation series, and those videos will be available 3 days before your examination. Okay, so a carton contains 20 fuses, 5 of which are defective. Find the probability that if a sample of 3 fuses are chosen from the carton by random drawing without replacement. Wow. It's clearly given without replacement. So we cannot apply binomial. So it's clearly hypergeometric. So look at this. There are capital N number of items. That will be 20. And A items are special, and here special means defective. So A is equal to 5. So you know this fact. And from this, a sample of 3 is selected, that also without replacement. Okay, so look at this. We can apply hypergeometric distribution here. So as usual, let's write the formula for x number of success. And before that, we have to write the notation. Capital X follows hypergeometric distribution for x number of success. So the lot size is 20 and the special items, that is the defective items, are 5, and the sample size is equal to 3. And first let's complete it. So this is n minus a, that will be equal to 15, and we need x number of success. So that means n minus x will be failures. So what's the required probability? Capital N, C, small n. And the numerator will be ACX and n minus AC, n minus x. So if you substitute, we get probability of x equal to x is equal to 5cx and 15c 3 minus x, the whole divided by 20c3. Okay, now let's read that question once more. Find the probability. So look at this. They are interested in the probability. At most, and what does at most mean? Less than or equal to. At most 2 fuses in the sample will be defective. So the required probability is probability of number of defectives less than or equal to 2. I'll repeat once more. Find the probability that at most 2 fuses will be defective. That means the number of defective fuses less than or equal to 2. And less than or equal to 2 means it can be 0, it can be 1, it can be 2. And if I invert it, I will get 1 minus probability of x greater than 2. We selected a sample of size 3. So the maximum possible number of defective fuses will be 3. So greater than 2 means there is only one number, and that is equal to 3. And now let's plug in the value x equal to 3. So that will be 5c3 multiplied by 15c0, the whole divided by 20c3. Now use a calculator, and the answer is 0.9912. Okay, so that's it. So I hope you understood when and how to use the hypergeometric distribution. So thanks for watching, and if you find the video useful, then of course like, share and subscribe. And don't forget, visit our website www.stmattube.com. You'll find a lot of free resources in it. You can access the formulae, you can access more videos like this. Anyway, thanks for watching, and I'll be back with another video very soon. So till then, bye.